Okay, boys and girls, today we are doing video notes over scale factor. If you are in my class, and that would be Mrs. Green's class, you're going to write this in your notebooks on page 66. I'm not for sure what the page number is for Mrs. Parker's class, but if you don't even have your notebook, or if you're not sure, just write it on a sheet of notebook paper, and then you can stick that into your notebook on the correct page. Okay, boys and girls, today we are doing video notes over scale factor. If you are in my class, and that would be Mrs. Green's class, you're going to write this in your notebooks on page 66. So if you would like to pause the video and go ahead and start writing this, that is fine. Or if not, you can just write as I explain. I'm not for sure what page you would be writing on if it's Miss Parker's class. But you know that you can always just get your sheet of notebook paper and write it down on that, and then just put it in your notebook on whatever page she tells you to when you get to class on Monday. Okay, so again, if you are in Mrs. Green's class, we are writing on page 66 in our notebooks, and should go over to page 67 by the time you're done. Okay, it starts off by telling us that for scale factor, there is a multiplicative relationship between the lengths of the corresponding sides called the scale factor. So what the word multiplicative means is that you're going to multiply. Just plain and simple. To find scale factor, you should be multiplying, or the scale factor is a number that is multiplied by something, some other number. Okay, you have the definition of scale factor that says it is the number multiplied to enlarge or reduce similar figures. Okay, scale factor may be a whole number or it may be a fraction. And since we know it can be a fraction, that means it may be a decimal. Okay, it is basically the ratio of any two corresponding lengths in the two similar figures. Okay, now the reason why it can be a whole number, if you're looking at your example right here, is because if I'm going from the smaller shape, which is A, to the bigger shape, which is B, then I know to go from smaller to larger, I should be multiplying by some whole number. Or it may be a mixed number, but it's got to have a whole number part in there. But if I am going from larger to smaller, it's like dividing. So if I'm dividing, it's pretty much the equivalent of multiplying by a fraction. Remember in class how we've talked about dividing by 2 is the same as multiplying by half, or dividing by 10 is the same as multiplying by 1/10. Well, that is the same exact concept that you're doing here. You just have to remember, if it looks like you should be dividing your numbers, you're actually multiplying by a fraction, because you have to multiply to do scale factor. So that is why when we look at our example right here, it says the scale factor of A to B is 3. Because if I'm going from A to B, it's basically saying I'm going, if we are marking our corresponding sides, with this being a rectangle, remember, all these sides are going to be congruent. So the 3 is going to correspond with the 9. So to get from 3 to 9, I'm actually multiplying by 3. And if I look at my top and bottom, remember, they would be congruent in a rectangle. So therefore, the 5 and the 15 are going to correspond as well. So that is why I would do 5 times 3 to get 15. So since I multiplied both the 3 and the 5 by 5, the 3 and the 5 by 3 to get the corresponding measure, then that is why I have a scale factor of 3. Now, the second part says the scale factor of B to A is 1/3. So that means if I go from B to A over here, means I'm going from larger to smaller. So you would think of that as like 15 divided by 3 is 5. Remember, dividing by 3 is the same as multiplying by 1/3. Just as 9 divided by 3 is 3. So dividing by 3 again is the same as multiplying by 1/3. And since scale factor has to be a multiplicative relationship, that's why we've got to multiply by the fraction. Okay, if you have not finished copying all of this down, you may pause the video now and finish copying it before moving on. Okay, this next part that you're going to write down is how to use the formula or the equation to find scale factor. In some instances, you may not be able to look at the figure and exactly be able to tell what you're multiplying by to go from one to the other. So in this case, use your formula, because the formula says that it is the image or the image divided by the original to get the scale factor. So since scale factor is a multiplicative relationship, which means we would usually multiply, our original by something to get the image. Well, if you don't know what to multiply by, wouldn't you usually divide the two numbers that you're given? So it's the same thing that you've pretty much been doing since you first learned to multiply and divide. You're just pretty much using your inverse operations again. So that is what this means. It says the image divided by the original equals a scale factor. And if you don't know the difference between the image and the original, the image is your new shape. The original is the old shape. It's whatever. The original is what you started with. The image is what you have created from the original. Okay, we've got an example here that I'm going to do with you. It is telling you that ABCD is similar to A prime, B prime, C prime, and D prime. And we're going to find the scale factor of ABCD to A prime, B prime, C prime, D prime. Okay, since we have rectangles, remember our opposite sides are going to be congruent in rectangles. Since these are the shorter sides in the bigger rectangle, they should be the ones with the 1 tick mark. And that means that these sides will get the 2 tick marks since they're the longer sides. And remember from when we did similar figures, sometimes you need to first redraw one of your shapes so that they can be facing the same direction so that you don't mess up when you're trying to either set up your proportions or get your scale factor in this case. So right now I'm just going to redraw the smaller shape so that it's facing the same direction as the other. And remember in class I showed you it's pretty much just like taking your paper and rotating it. So if I rotate my paper like this, then now my smaller figure is going the same direction as the larger figure was before. So keep in mind that the A is at the top left, the B is at the top right, C is at the bottom right, D is at the bottom left. So I'm going to draw the smaller one again. Remember, A was here, B was here, C here, D here. Now we pretty much have the letters in the same place as the larger figure. So between B and C is where the 5 was, and between C and D is where the 7 was written. So basically what this means is that my corresponding sides and lengths are going to be the 10.5 and the 7. And the other two that's corresponding would be the 5 with the 7.5. So now if I am following my formula up here, it says to take the the image, and in this case, the image is the one with the prime marks. Remember we talked about the prime notation in class on Thursday. So since I see I have 10.5, and its corresponding side is going to be the 7, then I would take that 10.5 and divide it by 7. Or, since they are similar figures, this could basically be the 7.5 divided by the 5. Either way, you should get the exact same answer. So now you're just going to divide either one of them and see what your scale factor is. Remember, bring your decimal point up to the top. So that gives us a scale factor of 1 5/10 inches. Or just basically 1 5/10. We really don't even need the label there. So what this means is, to go from my smaller rectangle to my larger rectangle, I'm going to multiply each measure by 1 5/10, or 1 1/2. Remember, this can also be 1 1/2. So that's where the fraction part comes in. Okay, if you do not have all this copied, you can pause the video and go ahead and finish copying it. If you have any questions about any of this that I just did, go ahead and start writing them on your post-it notes right now so that you can post to the parking lot as soon as you come into the class on Monday. Okay, it's done. Okay, now we have an example right here that I want you to try yourself. So again, go ahead and pause the video and try this example. You're going to do it just like the one that I just did for you. And we will go over it when you get to class on Monday. Okay, the last part of our video for today is just over proportions and scale factor. We're actually going to do some more things with the scale factor in class on Monday. I was just trying not to make the video too long for you this weekend. That will allow my students to go ahead and start on their 4.1 online. Hint, hint. Okay, proportions and scale factor. Remember, we are trying to determine what is it that I'm going to multiply by to get the other dimensions. So that means whatever I'm multiplying by is my scale factor. So remember, with proportions, if I'm going from this side to this side, I see that I'm increasing, so it's already going to be times something. So since 15 times 5 is actually 75, and when I come up here, when I go from 4 to 20, I know that 4 times 5 is 20, sorry. Then that means my scale factor is 5. There's your answer. That's all it is to it. Okay, and the second problem, this time I see the larger numbers are on the left side. So as I move from the left to the right, I see that they're getting smaller, which means usually I would be dividing, right? So if I'm dividing, that means I'm going to be multiplying by what? A fraction, that's right. Now, I know that this decimal down here is just throwing you off and you're over here scratching your head. So let's start up here at the 48 to the 6. Think that we should all know what to do to 48 to get 6. To go from 48 to 6, would we not usually divide by 8? But remember, scale factor cannot be dividing by something. So if I'm dividing by 8, then that means I'm actually multiplying by 1/8. So with this being a proportion, remember, whatever I do to the numerators, I should be able to do the same exact thing to the denominators. So that means my denominator, multiplying by 1/8 as well. And if you do the math, it's pretty much saying 12 divided by 8, and 8 does go into 12 1.5 times. So our scale factor in this case is 1/8. Okay, problem number 3. I want you to pause the video and try for yourself. But actually, you really don't have to pause because we're really right here at the end. So the last part is just basically explaining if your scale factor is greater than 1 or it's greater than 100%, because remember, 1 is a whole. Your whole percent is 100. So if you're more than that, then that means you are increasing your linear dimensions, which means you're making the shape bigger. Okay, if the scale factor is less than 1, which means it's going to be a fraction, or it's less than 100%, because that means it's not whole, then you're decreasing your linear dimensions, which means you're reducing your shape or making it smaller. And then when we get into class tomorrow, we'll be doing some practice where we'll be actually enlarging and reducing some dimensions, and you'll see how that actually is true. I mean, even if you look back here, our scale factor was greater than 5. Were we not increasing? Right here, our scale factor was less than 1. So we decreased. All right, guys. Well, that's the end of the video notes. Pretty short and simple and to the point. Again, if you have any questions about what went on in this video, please write them on a post-it note and please post them to the parking lot as soon as you come into class on Monday. All right, boys and girls, have a good weekend. See you Monday.